curious, analytical. Every enterprise AI project eventually hits the exact same roadblock, figuring out how to actually trust the answers. Right now, the standard fix across the industry is a framework called Retrieval-Augmented Generation, or RAG. The design is straightforward. Instead of letting a language model guess the answer to a question, you connect it to a verified database of your own company documents. When a user asks a question, the system retrieves the actual text and forces the AI to base its response strictly on those verified facts. Because the information comes from a trusted internal source, developers often treat the resulting pipeline as foolproof. They assume that pinning an exact document to a prompt strips away the AI's tendency to invent information. But underneath it all, the generative core of the model remains completely intact and highly active. The moment you expose that core to the unpredictable phrasing, typos, and strange logic of actual human beings, the system's behavior becomes opaque. Attaching a verified database does not repair a language model's fragile reasoning. It builds a multi-layered architecture where retrieval errors, context limits, and generation flaws compound together, creating failure points that can go undetected during development. Consider a typical customer interaction. A user asks a question completely unrelated to your business. Instead of gracefully refusing to answer, the AI grabs a vaguely related keyword, misinterprets the context, and confidently outputs a detailed, fabricated response. Then come the deliberate attacks. Users will inevitably try to bypass your safety filters, feeding the prompt hidden instructions or formatting tricks specifically designed to hijack the model's output. Even innocent queries cause friction. A user might submit a highly technical multi-part question, frame their request using confusing double negatives, or ask for information in a language the system was never optimized to handle. Now, multiply those edge cases. Imagine 50 different people submitting those exact complex, adversarial, and confusing queries at the precise same millisecond. A quality assurance team manually typing test questions into a chat window will cover maybe a few dozen predictable scenarios. They cannot generate the volume or the specific adversarial patterns required to expose deep, systemic flaws in the pipeline. Deploying a pipeline under these conditions means relying on live customers to encounter your system's breaking points. You end up fixing critical errors only after they have already damaged the user experience. To stop that from happening, developers use the RAG pipeline stress tester, built autonomously by Neo. It acts as a tireless, hostile QA team designed to intentionally break AI endpoints before they reach production. It targets the HTTP endpoint directly, launching a rapid-fire sequence of adversarial queries, pre-categorized to trigger specific failure modes. This flowchart tests the out-of-scope vector. If queried for missing data, does the AI invent a red hallucination or output a green refusal? It similarly fires prompt injections at safety filters, then duplicates across 5 more adversarial vectors, charting every possible response path. In a matter of seconds, this automated barrage maps the boundaries of the AI's logic. It identifies precisely what causes the system to fail, condensing months of human testing into one automated run. Once the specific vulnerabilities are mapped out, the test shifts from examining the types of questions to measuring the sheer weight of traffic. The tool forces the server to process the entire bank of adversarial queries under increasing pressure. Managing a load of 10, scaling to 25, and eventually 50 active users. Under this heavy load, structural weaknesses become obvious. The system monitors the API for total crashes and tracks whether the response time for 95% of the users suddenly spikes from milliseconds to seconds. This radar chart calculates the final results, grading the pipeline on a 100-point health score across 5 strict axes. Notice refusal quality. The score actively increases when blocking an unanswerable prompt, treating "I don't know" as a mathematically correct output. Scoring these variables strips away the subjective feeling of chatting with an AI. It forces generative text to submit to rigorous, quantifiable engineering metrics. This dashboard shows the final output of the stress test. You get a completely interactive HTML report featuring the overarching health score badge, latency histograms, and a hard breakdown of exactly which query types succeeded or failed. Having this granular audit trail provides a clear roadmap for optimization. Development teams can now identify exactly which documents cause hallucinations or which concurrent user loads trigger latency spikes, allowing for batch fixing before the first real user connects. For a long time, deploying AI meant putting a chatbot online and waiting to see what broke. Developers had to accept unpredictable outputs because they lacked the tooling to properly measure them. A retrieval pipeline is defined by its resilience under load. Automated adversarial auditing replaces guesswork with data, ensuring a system is as reliable as the stress it was built to withstand.